All right, good morning. How come I'm not seeing this? Oh, because I didn't turn it on. And I'm talking right now and I'm not prepared. So I'm sorry. Where's my remote? Alrighty, we have number 7 to do. Is that correct?
Yeah.
Number 2. Proof.
Yeah, we have the proof to do, right? I am still not seeing this. Why am I not seeing this? Oh, because it's not coming on. Is it coming on yet? Do you see anything?
Yeah. Well, it makes it dark right
Oh, I see it now. I see my hand. Alrighty. Pardon?
I think this is the one you wrote on, not a copy of the one you wrote on.
There you go. I thought you wanted a copy of what I wrote
this
on.
is like the exact one you wrote on.
Do you want it?
Yeah.
Okay. Do you want this?
No. Okay.
now.
Nick, I'm confused.
I think we're all.
All right, you ready?
Yes.
Now, the reason I held off on number 7 is if you look at some of the previous ones, it was a combination of the product rule and the chain rule. In this case, it's a combination of the chain rule and the quotient rule. And so what I'm going to do is, if you take a look at that, and it's right by these guys over here, that when you take the derivative, you never take the derivative of the inside. You take the derivative of the inside at the end and multiply by that derivative. So in this case, when I do this, and I'm going to use y prime in this case, I'm going to have a 2, and then I'm going to have 5x plus 2 over x squared minus 3 to the first power. So this right here is the g of x. Does that make sense? That I didn't take the derivative of it yet. I only took the derivative of this outside part times, now I'm going to take the derivative of the inside, and it is a quotient, so I'm going to use the quotient rule. And the quotient rule says what you're going to have to do is take the derivative of the denominator, you're going to take the denominator and square it, and then rewrite the denominator and multiply it by the derivative of the numerator, which in this case is 5, minus 5x plus 2 times the derivative of the denominator, which would be 2x. Any questions so far? No? Good. So now I'm going to simplify this, and I'm going to have 2 times 5x plus 2. I believe this is 5x squared minus 15. Now I'm going to have a minus 10x squared, I believe that's correct, minus 4x all over. Well, this and this are the same denominator, right? And I'm multiplying, I'm not adding. And so when I multiply, I'm going to get x squared minus 3 to the 3rd power. And my final answer is going to be y prime is equal to 2 times 5x plus 2 times a negative 5x squared minus 4x minus 15. Okay. Baya?
Wait, why'd you change x squared minus 3 to the third?
Right here? Good question. So over here I have 2 times 5x plus 2 over x minus 3. Excuse me, x squared minus 3. Would you agree? Right? And here I have x squared minus 3 raised to the 2nd power. And this is to the 1st power. So it's going to be 3 of them I'm multiplying. And it's because I'm multiplying and not adding. Nick, you know I called you Ryan last night? You know when I remembered that? At 1:30 this morning. I woke up and said, oh, I called Nick Ryan. I wonder why I did that. So I'm sorry for doing that. And now it's into the abyss as a permanent record until we have a solar burst and destroy all of our electricity, whenever that's going to happen. You guys know that's happening, right? Solar flare. Is that what they call them?
Yeah.
No. They say that all the time. We're going to lose all of our communications, right? Because we're on this grid type of thing that is ancient, right? You guys know that? Okay. Do they talk about that in science? I don't know what they talk about. Okay.
Do we want to keep it to that?
I keep it just like that. And you know what? I never multiply this out because we're going to find out. And I think Holland asked about it yesterday. Is we're going to have there's a turning around point here, right? Would you agree? Horizontal tangent line. That's where this numerator is equal to 0. And I can also have a turning around point that looks like that, a sharp point, correct? That's where this denominator is equal to 0. Or could be, not guaranteed, could be. That's where I would find it. Like a lot of times, I can find cookies in the cookie jar. But they're not always there. You know why? Because cookies are a food item we're not allowed to have at the house unless my sons are there. Because someone can't control himself when there's cookies around. A banned substance. Okay. Are we done with that? You guys do get to meet my wife. So in this class, we have Lemon Day, where we compute the volume of a lemon. And I personally serve you lemonade. It's a group quiz. You get to do it with another person. And the only questions you can ask me is, Mr. Kruger, can I have another glass of lemonade? Or do you have any more lemon bars? Because my wife makes lemon bars that are outstanding. And she serves them to you. So you get lemonade and lemon bars as you're computing the volume of a lemon. It's one of my favorite days. She loves it. Because she used to be an elementary teacher, and she says, high school people are so cool because they don't talk like first graders. Well, no kidding.
Wait, when is this day?
Why? Are you thinking about being gone? Are you allergic to lemons?
This is the second.
It will be either at the end of second try or the beginning of third try. Okay. Thinking about not skipping that day. Yeah, attendance is usually pretty good, but I do have a few people. Alrighty, so it's going to be this proof. Okay? And if you notice, when we prove, we use the limit definition. Does everybody understand that? And I have two to choose from, and I've always been choosing the bottom one, which just gives me the general derivative. Would you agree? This one, I'm going to use the top one. All right, and it's going to look like this. Pardon? No. I'm going to create a general point. Okay. So I'm going to take, but that's a great question because you do need a point, right? Which brings me up, when I'm done with this, I'll talk a little bit about the quiz. Okay? So I have the limit as x approaches c of f of g of x minus f of g of c all over x minus c. And what I'm going to do is I'm going to multiply. And I'm going to multiply the top by g of x minus g of c over g of x minus g of c. So this happens a lot in calculus proofs because calculus proofs are a lot of algebra proofs. I know you guys grew up with geometry proofs, but I can do this because I'm simply doing what? Multiplying by 1. Would everybody agree with that? And so now, since I have multiplication, I'm able to do this. Okay. What did I do there? I switched the denominators, didn't I? Yeah, it's a great question. Can I do that? In other words, I'm going to go up here. If I have 2 times 3 times 5 times 13, is that the same as 2 times 5? Are they the same? Yeah. Why? See, when I ask you why and you respond, that's your justification. Why can I do that? What? Okay, you need to speak louder because I'm deaf. I agree. What allows you to say that order does not matter in multiplication? The commutative property, right? Remember the old properties, associative property, the commutative property, right? Right next to, when you play Monopoly, aren't those one of the properties that would be on the board? That was a joke. That went poorly. Okay. You guys don't play Monopoly anymore, do you? Does anybody play board games in here? That's what we do at Christmas all the time. My sons are into role-playing board games. What?
Dragons.
No. What we're going to do, right, we're not done yet, okay? We are not done yet. We're almost done. We're done doing all the work, okay? Now we're going to take the limit. So I have a product, and when I take a limit of products, they are the products of the limits. So I'm going to take the limit of this one first, right? And the window, should give us some guidance. What is the limit? And by the way, you should know this for tomorrow. Somebody said it. F prime, well, not F prime C, but you're really close. Another letter in the alphabet. Just this one. It's not F, it's G prime of C. Correct? Because I chose F because function starts with the letter F, but I could have used G as my function, correct? Right? Now, times. What's the limit of that? Yeah. Right. The function's F, so it's going to be the derivative of F with what's my input that goes in it. It's not C, it's G of C. Okay? And so that means any constant, Cameron, okay? Yeah, I would need a point, but that constant is an element of my domain. That's how I get by. So it's really an X because it belongs to the family of X's. Okay, that domain. That's how we do it. That's it for notes. Okay?